So 3, 4, we're doing intercepts of graphs. The x-coordinate of a point where the graph crosses the x-axis. So we're talking these points right here. Those are my x-axes. Sorry, try that again. Those are my my x-intercepts. Okay? So then, if I'm talking about my y-intercept. So if I'm talking about my y-intercept, it's this point right here. Then, I actually want to do this. Not liking that. Okay? So if I'm talking about my positive function, it's the part that lies above. The positive part of this function is what lies above that. Okay? And then last but certainly not least, I'm going to do blue for this. This lays below. So all the stuff that is below. And when we talk about this, you're talking about the y values. What are the y values doing? Okay, so let's look at this very first one here. X-intercept. This point right here, we're talking it goes over 1, 2, 3 times, so that's 3, 0. We're talking about the y-intercept. It goes up 1, 2, 3, 4, 5, 6 times, so that's the point 0, 6. Now, if we were talking about all the stuff above the x-axis, remember we want to do interval notation on this. So and these are the y values. What are the y values doing on this? It starts at the x-axis. So it starts when y value is 0 and it goes up and up and up forever and ever. Oh, that was a weird way of trying to write infinity. It goes all the way up to infinity. Now, it doesn't include 0 because that is the actual line. The positive part is the stuff that is above it. Remember, the number 0 is not positive nor is it negative. So this is going to go below. So the low end of that is at the bottom. And the bottom of that, it's going to go on forever and ever. So it's negative infinity. It goes all the way up to the x-axis. So that goes up to 0. Okay, so I'm going to come over here and we're going to do this one. So where does it hit the x-axis? It's going to hit at the x-axis at negative 4, 0 and 3, 0. It's going to hit down here. If you notice, this looks like it goes a little bit below 12 or negative 12. I'm gonna say that this point is actually 0, negative 12. We might be a little off. It could be 0, negative 11.99. It's not real clear on that. So we're just going to use for this one 0, negative 12. Or if you wanted to say 0, negative 11.99. Now for the positive interval. So that's all the stuff. Do you know just how it goes from the x-axis? It goes all the way up above. So it's going to go from 0 to positive infinity. Now, this is not a line. So it actually comes down to here and it just stops. Oops, that was weird. It stops here. We only go from down at the bottom up to there. So the lowest it would be is either the negative 12 or the negative 11.99, comma, and it goes up to 0. Okay? So this one, it says the graph now, What I like to do sometimes is before I even look at what the equation is or the question is asking, I look at the graph because it gives us lots of information. The height of the ball is here, tells us what that graph's about. So this is how tall it is, this is the amount of time. You can kind of sort of figure out that it's talking about the ball being in the air. So this is my y-intercept. So that's the 0.04. This right here, I should have done that as a different color. Maybe I'll make it this. No. I want a different color altogether. Let's see. We'll make it black. 9, 0. So before we've even read this, we know that those are my two y-intercepts. So let's come over here. It says sorry about that. The graph shows the height of the ball for each second x that it is airborne. Use the graph to estimate the x and y-intercepts of the function, where the function is positive and negative. Okay. Now let's look at this. The height of the ball, so I want the x-intercept. So the x-intercept was 9, 0. So I'm going to come over here. I'm going to write 9, 0. Remember that the x was talking about time. This was talking about height. So what does this mean? It means at 9 seconds, the ball was on the ground. Okay? Then we have 0, 4. Again, this is time, this is height. At 0 seconds. Now, we could do a better job of saying at 0 seconds. We could have said when the ball leaves the person's hand, it is 4 feet off the ground. Okay? Now, it's asking, what is the positive and negative intervals? Well, look over here, guys. Do we ever go below the x-axis? We don't. So we only have a positive function. And these are y values. It gets all the way up to here. It gets up to the point, is that 39? 39. So the tallest it gets is to 9. So it starts at 0 and goes up to 9. And hits 9, sorry. Should have that as a bracket. Okay. We're going to come over here. We're going to do a table. Now, before I even read it, let's look at it. Okay, so I have my intercept here and my intercept here. Well, which one is which? Okay, remember x-intercept is when the y value is equal to 0. X-intercept is when the y is 0. Y-intercept is when the x is 0. So be careful when you're doing this. So if I look at this, that means that the x-intercept is this one down here. So 40, 0. The y-intercept, I'll change colors for it. The y-intercept is right here, so 150. So let's look at what the problem actually says. Violet starts the semester with $150 in her student lunch account. Each day, she spends $3.75 on lunch. The table shows the function relating the amount of money remaining in her lunch account to the number of days Violet has purchased lunch. So when we do this, the X's were days, okay? So these are the days. And then this is her balance in her account. So what does 40 mean? Violet has no money in her account at 40 days. Okay? Then this one. She starts the semester on day 0 with $150 in her account. Okay, now, roots. The solution of an equation is the value that makes the equation true. The 0 is the x-intercept, okay? So, if I look at these, some of you are going to look at it and go, I mean to do that. Right here, you're going to say, oh, I know how to solve that. 3x equals 6. We're going to divide by 3. X equals 2. So this is my, this right here is my solution. It's my root. I know that x equals 2. But when we're dealing with related functions, it needs to have a y equals or an f of x equals. So what we're going to do is we're going to take the same equation right here, and we need because it's talking about the x-intercept, so that means the y value is 0. So we're going to solve so that we get 0. So I'm going to subtract 6 from both sides and get 3x minus 6 equals 0. Well, didn't we just say the y value is 0? So what I can do is I can replace this like this, or, okay? This is not the solution to this. This is the relative function, okay? So if I want the solution is actually the point to 0, because it's the x-axis, or the x-intercept. I keep saying x-axis. So, first things first, I'm going to solve this. So I'm going to solve it just like we've been solving things. We're going to solve it. So x equals 3. Awesome. But now I want to make this the relative. I want to make a relative function. So I'm going to subtract 1 from both sides. I'm going to get negative 2x plus 6 equals 0. So I'm just going to leave it as y. Oh no, I'll change it to both of them. So it can be either one of these, okay? It can be either one of those. So what we said a minute ago, I don't want to do that. I want to do purple. We got this right here. So if I plugged in 3 for this equation right here, if I plugged in 3, I would get negative 6 plus 6. That would get me 0. Well, isn't that what that says right there? That the y value would be equal to 0. So I'm going to come down here and I'm going to go to 3, 0. Okay? I'm going to go to 3, 0. And then my y-intercept. My y-intercept means that the x value is 0. So if I was to plug in x is 0 right here, I would get 0 plus 6 equals y, so 6 equals y. So that's 6. So 1, 2, 3, 4, 5, 6 right here. I don't know, that's a horrible line. There we go. But my solution to this is right here. My solution to this is the point 30. This one right here. You don't know how to do quadratics yet. So we're just going to find the relative equation on this one. And what I find is interesting, for this, is what I'm doing right now, they teach it in the next section. So I don't know why they have it here. So I always like to, before I do that, I forgot to put it like so. Okay, I'm going to replace x with 0. So 0 minus 0 plus 3 equals y. So that means that 3 would equal y. So I plot that point. Then, if I plug in 1 minus 4 plus 3 equals y. So 1 minus 4 is negative 3. Plus 3 is going to be get me 0. So the point 1, 0. I don't want to do green. We'll do blue. So now I'm going to plug in 2. So 2 squared is 4. 4 times 2 is 8 plus 3 equals y. So that's going to get me negative 4 plus 3 is negative 1. So the point 2, negative 1. We'll do red. I'll do 3. So if I plug in 3, that's going to get me 9 minus 12 plus 3 equals y. That's going to get me 0. So 3, 0. And last but certainly not least, I'm going to plug in 4. I would get 16 minus 16 plus 3 equals y, so that's 3. So that's the point 4, 3. And I'm not very good at drawing these. Not bad. Make sure I have my arrows on. Okay. Where does it hit the x-axis? Hits here and it hits here. So my solutions, actually I want to do this. Right there. And right there. So the points 1, 0 and the point 3, 0. Those are my solutions. Okay, so over here, if I was to solve this, I would subtract 4x from both sides. I would get 3 equals negative 5. And you would say, no solution. But I want to find my relative function. So I do like, actually, you know what I'm going to do? I'm going to start from this step right here. I needed to get it to equal 0. So if I get it to equal 0, I'm going to get 8 equals 0. So that means 8 equals y. Well, if I was to draw 8 equals y, 6, 7, 8, it would be this line right here. Does it ever hit the x-axis? No. So it is no solution because it never hits the x-axis. Okay, you're going to come down here. You're given this equation. and it wants you to find the relative function. So if I've been given this, and I want the relative function, that means I'm going to subtract 2 from both sides. Ooh. That's not quite that line, is it? So the question may have been, well, how do you know which direction to go? Well, on this one, isn't this a negative slope? Isn't this a negative slope? So I would need to subtract that to the other side. So negative 1/2 x plus 2 equals 0. So that means that y equals negative 1/2 x plus 2. What is my 0? My 0 is right here. 2, 3, 4. So my 0 is 4, 0. On this one, look, it never hits the y or the x-axis, so automatically that's no solution. Okay, we want this to become out a positive y value. So 3x plus 7 equals 3x plus 2. Subtract 3x. Get 7 equals 2. I want it to come out positive. So I get 5 equals 0, which means y equals 5. Last but certainly not least, x squared minus 6 equals x. I'm going to subtract this to the other side because we want it to be positive, so the x squared needs to be positive. So y equals x squared minus x minus 6, and my zeros. Right here, I want to say about 3, 0, and here, negative 2, 0. So this would be 3, 0, negative 2, 0. Okay. Haley is ordering invitations for a graduation party. She has $40 to spend. Each invitation costs 96 cents. The function m equals 40 minus 96 cents. P represents the amount of money Haley has left after ordering party invitations. Find the zeros of the function. Describe what it means. So this means that, oh no, it does not mean that. Again, no. It means I plug in 0 for the y value. Now, in this instance, the y value is actually the m value. So we're going to replace m with 0. Okay, so I'm going to subtract 40 from both sides. I'm going to get negative 40 equals negative 0.96p. I'm going to divide by negative 0.96. Okay, that will come out to be a positive number. So 40 divided by 0.96. Try that again. 40 divided by 0.96. Well, okay. Well, that's interesting. Okay, so what does that mean? I got 41 2/3. What does that mean? Well, this is the number of invitations. This right here is the amount of money. When she sends 41 2/3 invitations, she will have $0 left. Now, do you actually send $41 or 41 2/3 invitations? No. But that's where you would hit 0. Okay? So she would only send 41. So she would have a few extra dollars in her account. But when we're graphing it, that's what it means. So I would come over here to 41 and a little past 41. Okay? Then, I just solved it algebraically. Okay? What happens if I plug in 0 for x? So you don't actually have to solve this. You should be able to do this off the top of your head, because didn't she start with $40? So yeah, it would go here. And voila. Okay.